Hi, I'm Parveen. Today we'll deal with the chapter Pair of Linear Equation 2 Variables, Class 10. Linear equation. Linear equation are equations of degree 1. The maximum degree is 1. Before going for two variables, let us quickly recall what was linear equation in one variable. A linear equation in one variable is generally expressed as ax plus b equal to 0, where a should not be equal to 0 and a, b are real numbers. Now linear equation in two variables are expressed in the form ax, that's the first variable, by plus c is equal to 0. Here also both a and b should not be 0. So a and b not 0 and a, b, c are real numbers. Now a linear equation one variable or two variable, where do we use all this in real life? It's very important to understand where do we apply maths in real life. So first we'll consider one variable situation, which is okay, say you buy 3 pens and you have to pay rupees 15. Somebody asks you how much for one pen, readily you will have the answer, it's rupees 5. It's nothing but an algebra here. If you take the cost of one pen as x, for 3 pens the cost would be 3x. So 3x would be equal to 15. X would be 15 by 3. The value of x is hence 5. So cost of one pen is equal to 5. Now 3x equal to 5 is a linear equation in one variable and the solution I got here is 5. So one variable linear equation always have only one solution. It's very important to remember linear equation one variable has only one solution. Now let us consider a situation with linear equation two variables. This time let's buy 2 pens and color papers. Okay, let's buy 3 color papers and say you have to pay rupees 130 and then you have to buy 3 pens and 4 colored colored papers where you paid off rupees 70. Now how much would one pen and one colored pencil cost, or how much would 5 pens and 5 colored papers? This is where we can apply a real life situation for two variables. 2 pens, like take the cost of one pen as p. So 2 pens cost would be 2p. And colored papers, one colored papers cost be c. So it would be 3c. Since we have 3 colored papers, this is 130 since the total is 130. Likewise, for the second situation, I would get 3p plus 4c is equal to 70. Now solving them, I can find out the value for 1p, that is 1 pen and 1 colored paper, using algebraic methods or graphical methods. So this time, let's buy 2 pens and 3 colored papers. Where you have to pay say rupees 130. And next day you go and buy 3 pens and 4 colored papers. And this time you had to give rupees 70. Now third day you want to buy 4 pens and 5 colored papers. How much do you have to pay? Now this is a situation where I can use two variables to solve it. If I take the cost of one pen as P, so 2 pens would be 2P, and colored paper, one colored paper's cost be C, so 3 colored paper would give me 3C. So the total cost are 130. Same way, when we have 3 pens, I had to give 3P plus 4 colored papers. The total cost was 70. So in solving this equation, I can find out how much would 4 pens and 5 colored papers cost you. So this is a simple example where we can use linear equation two variables in real life. Now solving linear equations, we have algebraic methods and graphical methods. Last year in class 9, we have already learned graphical method. So this year, we will first refresh that before going for algebraic methods. So let's consider a geometrical view of a linear equation. X plus a very simple equation, x plus y is equal to 4. Just to refresh what we have learned before. So here I have to try values. So let me take x as 0. So I get y as 4. Now I'll try y as 0. So that means x is going to be 4. Because 4 plus 0, I get it 4. Now let me take x as 1. So y is equal to 3. I'll plot the graph here, marking the axis. My values are all positive. 0, 4. So let's mark here. Here is my 0, 4. 4, 0. 4, 0. 4 in the x-axis. 0 there. 1, 3. 1, 3. So when I join off, I get a straight line. So linear equations always have straight line. And this line which I have drawn here is nothing but the equation x plus y is equal to 4. As you see, you can have infinite number of solutions for them. These three solutions are nothing but the points on the line x plus y is equal to 4. So all solutions can be the points of the line that represents the equation. And every point on this line is actually the solution for that equation which the line represents. Each solution xy of ax plus by plus c corresponds to a point on the line representing the equation and vice versa. That means every solution is going to be a point on the line which represents that equation, and conversely, every point is the solution for that equation, linear equation in two variables. Let's do more graphs here. I'll take the first pair. X minus 2y is equal to 0. 3x plus 4y is equal to 20. I have the table already done here. So when I've given x is 0, y has also been 0. When x is 2, y has become 1. Somebody don't remember, we'll just do it off again. X minus 2y is equal to 0. So I'm trying x as 2. So 2 minus 2y will be equal to 0, isn't it? So 2 would be equal to 2y and y would get the value 1. You can find one more. Say if I take x as 4, the equation becomes 4 minus 2y is equal to 0. 4 is equal to 2y. Y will be equal to 4 by 2. So I can give that value also there. When x is 4, y is 2. Same way 3x plus 4y is equal to 0. X is 0, so this becomes 0. Plus 4y is equal to 20. So 4y is equal to 20. So y is equal to 5. So we get the point 0.05. When y is 0, I get the value 20 by 3. Though it's not a whole number, it's not easy to mark in the graph. Still the solution holds. So you can write it in the table. Same way, if I put x is equal to 4, I get the value as y is equal to 2. That is 3 into 2, 6 plus 4y is equal to 20. 4y is 20 minus 6. Let's consider the equation x minus 2y is equal to 0, 3x plus 4y equal to 20. We have done the table here and drawn the graph. We'll go through the table once. X minus 2y is 0, x was 0, y is 0. So it's tallied here. When x becomes 2, y is becoming 1. And you can check it here. X minus 2y is equal to 0. When x is equal to 2, this implies 2 minus 2y is 0. So 2 is equal to 2y. You get y is equal to 1. You can find one more value here. Say put x is equal to 4. So the equation becomes 4 minus 2y is equal to 0. You can take any value which gets satisfied. 4 is equal to 2y. Y is equal to 2. So I can fill the table here for 2. Second equation, 3x plus 4y equal to 20. Always try zeros first. So I've put variable x as 0. So this cancels off, becomes 0. 0 plus 4y is 20. So y is equal to 20 by 4. So it is 5. 0, 5. When I take y as 0, here I get a fraction 20 by 3. Difficult to plot, but still the solution holds. So you can keep it in the table. We need minimum 2 to draw. Then I try x is equal to 4. So put x is equal to 4 here. So 3 into 4, that becomes 12 plus 4y is 20. So 4y would be 20 minus 12. That is 8. So you get y is equal to 2. Now you notice here we got 4, 2 solution for both. And when you check the graph here, the meeting point of both the lines is also 4, 2. Check the solutions, how to mark 0, 0, that's marked here, origin, 2, 1, 4, 2. Likewise for the next graph, 0, 5, marked here, 4, 2. And when they are extended, they meet at this point. So for this pair of equations, x minus 2y is equal to 0 and 3x plus 4y is equal to 20. The meeting point of the two lines is 4, 2. So the solution is the point x equal to 4, y is equal to 2. This is how we solve a linear equation graphically. So get the two tables for the equations, plot it in the graph. If they meet, that meeting point is the solution. So for this equation, I've got two lines, straight lines, which are intersecting. Need you to observe this. We have what lines here? We have here intersecting lines for pair of linear equation in two variables, the first pair which I have taken. Let us proceed to another one. Okay, here we have a blank table. Let's fill it off. X plus 2y is equal to 4. 2x plus 4y is equal to 12. So the first table, let it be for x plus 2y is equal to 4. Second table, we'll take it for 2x plus 4y is equal to 12. Okay. So here is my x and y. I'll try x as 0. So 2y is equal to 4, y is equal to 2. Same way, I have put y as 0. So x is clearly 4. So I've got two sets of values there. x, y for 2x plus 4y equal to 12. Again 0, 2 into 0, 0. 4y is equal to 12. So y is equal to 3. If I try y0, 4 into 0 is 0. 2x is equal to 12. So x is equal to 6. So with these points, let us try the graph. So here when I graph is drawn, see the points marked here. They are not at all meeting. Rather, we have parallel lines. So the second pair of equations which I took 2x plus 4y minus 12 and x plus 2y minus 4 is equal to 0. And when we drew the graph from the values we got parallel lines. So since they are parallel, they are not going to meet anywhere. And so we say the solution is not possible. We have no solution possible if it is parallel lines. First one, we had got intersecting line, we have got a single point, we had got a unique solution. The second pair of linear equations which I have taken, we have got parallel lines, so no solution is possible. Now let's take a third pair. 2x plus 3y is equal to 9, 4x plus 6y is equal to 18. The table is done. So we have done it earlier, giving values for x and y. So here we don't find. Now the next pair we will check is 2x plus 3y is equal to 9 and 4x plus 6y is equal to 18. Usual manner, taking values for x of y, x0 and y0. I have got their pairs 0, 3, 4.50, 3, 1. And for the second table also we have 3 set of values. When we plot here, you can see we have only one line. Rather, the values are just the same. So we have the same line. We have a better word for that. We call it they are coincident lines. So we have a single line and every point is a solution there. So infinite number of solutions are possible. So if it's a coincident lines, we have infinite solutions. First one we got intersecting lines. We had only one solution, unique solution. The second example which we tried, we got a parallel lines. So there is no solution possible. And finally here, when we consider this pair of equations, we got a single line, we got a coincident line. And they have infinite solutions. So all these points are solutions. Now when you consider a linear equation in two variables, generally we express it as ax plus by plus c is equal to 0. But as you know, so we are taking two equations at the same time, pair of linear equations we are taking. So to express it in a general form, we will have a slight modification there. We will take it a1x plus b1y plus c1 is equal to 0. Second equation in that pair, a2x plus b2y plus c2 is equal to 0. Now these were the three lines which we had considered, three pairs which we had considered. So when I took the first pair we have got intersecting line, the second pair we got coincident line and third pair we got parallel lines. Let us just consider their coefficients. Just now as we discussed, let me write out a1 here. What is a1 here? In x minus 2y, a1 is 1. What is b1 here? b1 is minus 2. c1 is equal to 0. Now in the second pair, a2 is equal to 3, b2 is equal to 4, c2 is equal to minus 20. Now we will find a ratio between them and try to see is there a relation possible. Now when I find a1 by a2, I get it here as 1 by 3. When I find b1 by b2, I get the ratio as minus 2 by 4. Even if I try c1 by c2, 0 by minus 20, it's 0 itself. So a1 by a2 and b1 by b2's ratios are not equal. So when A1 by A2 is not equal to B1 by B2, the lines you had got was intersecting. Okay, and you remember what solutions we had? We had a unique solution there for intersecting lines. Now in coincident lines which we got, coincident, that means the solutions are going to be infinite. Let's check out the same ratios here and see if they have a particular nature. A1 by A2, 2 by 4, we can write it directly. 2 by 4 means it is 1 by 2. B1 by B2, B1 is 3, B2 is 6. 3 by 6, again 1 by 2. C1 by C2, minus 9 by minus 18. Minus get cancelled off, so it is 1 by 2. So all three ratios, the value is 1 by 2. So we conclude them as A1 by A2 is equal to B1 by B2 equal to C1 by C2. So if the ratios are equal, we get coincident lines and they are going to have infinite solution. The final pair which we considered, we had x plus 2y minus 4 is equal to 0 and 2x plus 4y minus 12 with parallel lines. When there was parallel lines, they were not at all meeting, so there were no solutions. Now try the ratio of A1 by A2. A1 is 1 and A2 is 2, so 1 by 2. No coefficient, so it just means it's 1. B1 by B2, can write B1 by B2. B1 by B2 is 2 by 4. 2 by 4 is also 1 by 2. A1 by B2 is 1 by 2. B1 by B2 is also 1 by 2. So let's find out C1 by C2. C1 by C2 is minus 4 by minus 12. That is 4 by 12, which is 1 by 3. What can I conclude here? I can conclude A1 by A2 is equal to B1 by B2, but not equal to C1 by C2. So if the ratio is of this form, they are going to have no solutions or parallel lines. So once a pair of linear equations are given to you, without graphically finding the solution, you can conclude from the ratio given what type of solution you get or what type of lines you will get. So if A1 by A2 is equal to B1 by B2 is equal to C1 by C2, you're going to get infinite solution with going to be coincident lines. Finally, if A1 by A2 is equal to B1 by B2 but not equal to C1 by C2, there are going to be no solution and the nature is going to be parallel. We have consolidated that in a table here. You can see the first column A1 by A2, B1 by B2 the second, C1 by C2. The ratios comparison and your graphical representation, you are getting intersecting lines means they are A1 by A2 is not equal to B1 by B2 and they are going to have exactly one solution, unique solution. If all the ratios are equal, it is coincident lines, infinitely many solutions. If A1 by A2 is equal to B1 by B2 but not equal to C1 by C2, they are going to have parallel lines and there is going to be no solution. It's a very important conclusion which you should be very thorough. You'll be doing more problems based on that.